Hello, and welcome to my presentation of Lab number 2, which was a revisit of Lab 1. So here's the introduction. The purpose of the lab was to compare the electric force from the point charge model to the floating tape in Lab 1 to a line of charges model. As we can see down below, those were the results. The charge for using the point charge model was found to be 1.167 times 10 to the negative 8 coulomb. And for the line charge model, it was found to be 2.37 times 10 to the negative 8 coulomb. Here are the fundamental principles involved with this lab. First, we have Newton's second law, which is, as we all know, F net equals mass times acceleration. Secondly, we also have Coulomb's law, which is shown below, which is 1 over 4 pi epsilon naught times Q1 times Q2 divided by R squared, and then multiply all that by R hat. And gravity is also the last fundamental force we need to know for this lab. Its equation looks quite similar to Coulomb's law. So the only material used for this lab was GlowScript, as it was completely computational. So the initial conditions of the lab were that the tape mass was 2 times 10 to the negative 4 kilograms. The tape length was 0.2 meters. The tape width was 0.02 meters. And the tape distance was 0.05 meters. So here are the system and surroundings for the lab. The system, as we can see here, is the red tape, which is tape B, and the surroundings were tape A and the earth and everything else. So here are the calculations that were performed for this lab. The gravitational force was found to be 1.962 times 10 to the negative 3 newtons, and the electric force was found to be the exact same. This makes sense because the tape was floating in equilibrium. And the electric charge was found to be 2.37 times 10 to the negative 8 coulomb. And that equation that was used there was for the electric field of a rod. So here is the initial conditions of the computational model that was used in this lab, seen below. And here are the important functions that were in the computational model for it to work. The function at the top is the function that was used to calculate the electric field, and the function at the bottom was the function used for calculating the electric charge through the line of charge model. Here are some other important functions throughout this program. This is used to calculate superposition, and in order to do that, it utilizes for loops, as we can see in the picture there. So here are the results of the computational model. The white arrow is the electric force, the green arrows were the electric field, the red dots represent the top tape, the blue dots represent the bottom tape, and the yellow arrow represents the gravitational force. As we can see down there below that diagram, it shows the computationally calculated magnitude of electric force and magnitude of gravitational force. So some of the assumptions made were that air resistance and friction were negligible, that each piece of tape has the same charge, and also that each long piece of tape was treated as a point charge. So some possible sources of error include experimental measurements not being precise, also loss of charge due to handling or to the environment. So what if each of the tapes were modeled as a single point charge, like we did in the previous lab? Well, if they were modeled as a single point charge, it would be less accurate, because in real life the tape did have a length. So as we can see there below, those are the two results from the point charge model and the line charge model in comparison to each other. Another question. So why do these estimates differ? And which value is more likely to be closer to the real value? And why might this be? Well, these estimates differ because there are innately different levels of precision depending on what model you use. So the line of charge model would be more accurate because it actually takes into consideration the tape's length, unlike the point charge model, which just generalizes to a single point, which is not how it is in real life. And thank you for your time and attention.